Thank you very much. Good morning, everybody. Thank you for the introduction. I would like to take the next 20 to 25 minutes to give you an idea about application security, why it is so important, what the drivers for organizations are, and would like to take you on a journey on how our customers, and there are some really very famous names most of you have surely heard about, take our solutions to help to create secure software in the first place, because this is far easier than trying to protect afterwards against vulnerabilities. My name is Gunnar. I'm with Hewlett-Packard for 11 years now, and 3 years in the enterprise security division, responsible for solely the application security pillar in all of Central and Eastern Europe, including Russia and the CIS states. So basically, this is pretty obvious. Every organization wants to avoid to end up in the press. Every other week, you read about breaches. The most prominent ones over the last 2 years probably have been Sony Media, PlayStation Network, RSA, and a lot of others. They got breached, it got public, and of course, the press just jumps on it, and it creates a huge damage to those organizations. The drivers behind this are confirmed also by all leading analysts as of today. If you look at Gartner, NIST, RSA, Sensic, they all state that today, somewhere between 80 and 90% of all successful breaches, they happen directly on application layer. And this is why, first of all, the organizations are quite well protected in terms of perimeter defense. On their infrastructure, their network, their hardware, they have done quite a lot of investments. About 90% of their security spendings in the past went into that area, and there they are doing quite well. But now the attackers change their patterns away from trying to get to the network. They rather try to find vulnerabilities right on the application layer. And surprisingly, applications tend to be full of vulnerabilities. As Sensic analyzed earlier this year, they state that 99% of all web applications worldwide are vulnerable to attack. And I can confirm this. We work with clients analyzing their applications, their web applications each and every day. And we never had a case where we did not find at least a handful of vulnerabilities. And for the bad guys, it's obviously enough to find and exploit one vulnerability. So it doesn't help to find 5 out of 10. The hackers, it might take them half an hour longer, but they will find one of the other remaining 5 that are not fixed. Hewlett-Packard ran a research study accompanying this trend that we see in the market ongoing over the last 7, 8 years, and now with increasing momentum that organizations look more and more into their application landscape. Because in the application landscape are all digitized IT processes. Most businesses quite heavily rely today on IT-based processes. They have all their data, financial data, customer data, research data, business processes, trade secrets, everything is stored in those applications. And this is where the bad guys are actually looking for. And today, it's not what we are seeing, that it's like scripting kids who just want to prove, oh, we are good, we break into the systems. Today, it's professional organizations who really try to do espionage, sabotage, or whatsoever. So the result of this research study, end of 2012, released by Hewlett-Packard together with Ponemon, a security research agency in the US, they were analyzing 6 countries. And what they found is that the cost for dealing with cybercrime is continuously increasing for organizations, which is not a surprise. But the second graph from the left, the number of successful attacks, successful breaches per week has doubled over the last 3 years from 2010 to 2012. And the time to fix those vulnerabilities is also continuously increasing. And this is why, because the frequency, the intensity, and the sophistication of these attacks is continuously increasing. And this is why overall, of course, the cost to deal with cybercrime is continuously increasing for organizations. So in terms of looking at application security, the idea when the company called Fortinet was founded in 2000, later acquired 2007 by Hewlett-Packard, started to look in when should we address application security. It is easy to find, for example, by using penetration tests, vulnerabilities for applications that are in a pre-production or already in a production mode, but then it's quite late. If you find a ton of vulnerabilities, what are you going to do about it? Therefore, the idea was raised to implement and help organizations to identify and fix those vulnerabilities right when they're introduced. If you look at this graph here on the very left side, 80 to 90% of vulnerabilities are introduced during the coding phase. Developers write new code each and every day. Typically, we have never seen really any developers that have been trained to develop secure code. They're happy if the application does what it's supposed to do and if they can deliver in time and budget. Then they're already happy. But nobody spent a thought on security. So the idea is to help identify and provide guidance on how to fix those vulnerabilities right when they're introduced. And of course, there's also a valid business case behind this. If you look at the dollar numbers there, this research study is quite old. It's almost 10 years old. No, it's 17 years old. The cost to find and fix a vulnerability is about $25 if you do it right during coding phase. If you do it in an application when the application is already in production, the cost is 30 to 40 times higher to get it fixed. And this is the idea when Fortify initiated as one of the first companies worldwide to look into static code analysis, reviewing really the source code. Because in the source code, this is where the vulnerabilities are embedded. And today, of course, the portfolio is rounded up. And what we see as components of the mature software security assurance program begins with static assessments, helping organizations to identify and fix 80 to 90% of the vulnerabilities right during the development process, followed by dynamic assessment, which is classic, typically automated penetration testing, allowing specifically for web applications to identify an additional 10 to 15% of vulnerabilities that come only into context when the application is already compiled. And what we call real or runtime assessment. These are technologies, for example, in conjunction with the SIEM system, Security Information Event Management. Typically, in those systems, the application landscape is a blind spot. And we have technologies that allow application logging and report, for example, user interaction in the application to a SIEM platform. Or provide also interim protection, similar from a concept like a web application firewall, to vulnerabilities explicitly for applications that are already in production, because it's not that easy if you have, let's say, 500 vulnerabilities to fix in an application that is already in production. The developers need the time to go back into the remediation process, go back in the source code, find and fix a vulnerability. So we see software security assurance rather as a methodology, right during the development lifecycle, write code during the day, get it scanned overnight, in the morning, fix the identified vulnerabilities. Of course, hard, like for every security solution, is the most up-to-date security vulnerability database. HP Enterprise Security has about 1,500 researchers overall. And in the area of application security, those folks are solely focused on identifying new vulnerabilities that are unknown today in programming languages and verify that those can be exploited. And of course, all kinds of reporting and governance functions for the Chief Information Security Office in an organization to watch the trending and the overall security maturity, I would call it, of the existing and operating application landscape. Just to give you an impression, today we are able to identify 563 categories of vulnerabilities across 21 supported programming languages. So we are always watching the market space, what languages are making their way in the application landscape. So you see ABAP for the SAP world, of course, which is a very dominant thing. Then all the mobile languages for mobile applications, for Windows, BlackBerry, Android, and iOS for the Apple world, of course, are supported, and all web-based languages, of course, Java, .NET languages, C#, C++, and so on. Behind the link, in the little gray box on the left-hand side, there's a link. If you're interested to have a closer look, there's a publicly available list and description of all those 563 categories of vulnerabilities that are identified and have a risk to be exploited. Just to give you an idea about the two technical concepts of static code analysis and dynamic penetration testing, I would like to start out with code analysis. Code analysis is not just about pattern matching, which would be similar to, let's say, Microsoft spell checker. You can imagine you miss a letter in one word, Microsoft underlines it in red. Even so, maybe the whole text block doesn't make sense at all, but it just looks for a certain pattern. This is not what Fortify does. Fortify, on the left-hand side, you see the 21 programming languages. What we do is we translate them into what we call a neutral format, the Fortify intermediate model. There's two reasons why we do that. First of all, if we add language number 23, and 22, 23, and so on, we only need to create a new translator. So the time to add a new language is much faster than if we would have to rewrite the whole analysis procedures for each and every language. Excuse me. Second reason, which is by far more important from our point of view, is if you look at a modern web application, you easily have 3, 4, 5, 6 different languages. You have Java, .NET components, maybe C# in one application. If we would have to scan each code base on its own, what would happen? We would lose the whole logic of the program. And the clue in code analysis, a lot of vulnerabilities come into context or become into context only if you understand the whole logic of the program. How is data coming into the applications? How is the information passed through the application, and where is information leaving the application? Where are passwords coming from? Are they entered, are they stored in the application, like hard-coded passwords? Therefore, what we do, we translate all languages in one model, so that allows us that we still have in the Fortify intermediate model the whole logic of the application, just in a neutral format, and then we run what we call the Fortify global analysis. And this is, simply speaking, trying to understand what does the application do? How is the data flow in the application, the control flow, the configuration, the structure? Overall, there are 7 different analyzers running. So the tool translates, then understands the whole logic and data control flow of the application. And after this, we map against the so-called vulnerability database to map if any of the known 563 categories of vulnerabilities can be applied. And the results then simply is stored what we call the FPR. You see this little white box on the right-hand side, Fortify project repository. This is the result of a static analysis of a code base, which is stored, and then certain roles in an organization, an auditor, or the developers, or the CISO can access those results and take it from there. From an operation process, of course, it's not just about finding vulnerabilities. This is pretty easy. This is a proven technology around for 13 years now. It is more important, what do you do with those vulnerabilities? Because the benefit for an organization is only if they have a plan in place on how to fix those vulnerabilities. Because overall, you want to reduce dramatically the number of high, medium, and critical vulnerabilities in your application landscape. So you find this kind of setup in more or less every developing organizations, independent if software is developed internally or externally. Or in a hybrid setup, you have the development folks, the programmers on the left-hand side, and the security people on the right-hand side. So software is produced each and every day. It gets scanned. resulting in the 45 project repository. Then it's analyzed or audited by what we call a project security lead. He verifies and says, yes, these vulnerabilities are critical and exploitable. They need to be fixed. Go to a bug tracking system, go back to the developers. They look at them, fix the code, check the code back in, and hopefully next day, in the next scan, those vulnerabilities are gone, and the ticket can be closed in the bug tracking system. Of course, this is not a one-time process. You do it each and every day, over and over again, and by doing this, you finally fortify your application. To fortify is an English word. If you translate it, it means you harden the attack surface of your application. So this was a Fortify marketing slogan: find, fix, fortify. And of course, the security folks are monitoring overall. The CISO wants to know, is my maturity level in terms of security dramatically increasing? That means the number of vulnerabilities is going down. And finally, maybe for a web application, an additional penetration test is raised. Just to give you an idea, as you can imagine, when the product was released in 2000, the early adopters were in the banking and finance sector. Today, 10 out of 10 leading banks worldwide use Fortify. You see some big names: Deutsche Bank, BNP, ING, Commerzbank, Royal Bank of Scotland, Wells Fargo. You name it, they have it. So this is really, they used to be probably 50% of the market share. But then we saw also all these software OEMs: Microsoft, SAP, Apple, Adobe, McAfee, EMC, HP Software. They all use Fortify also to ensure the secure coding of their developers. At the moment, we see huge momentum from telcos and energy companies, because more and more move their business models towards whatever, internet-based communication channels. And government, public sector, more and more countries, cities, communities, they move to e-government, e-taxes. So they need to care about their application security as well, because people start communicating over the internet with those organizations. The retail organizations, eBay, Amazon, Dell, airlines. Last but not least, over the last 1.5 to 2 years, we saw strong momentum coming from the technology companies, which are not mainly doing business over the internet, but they are afraid of espionage, like the automotive industry, Volkswagen, BMW, Mercedes, General Motors. They all are afraid that certain organizations try to steal their research data, their newest inventions. And it's not just our customers, which are quite impressive. Also, our leading technology is confirmed by Gartner Group, just recently released in July 2013, in their first time overall Magic Quadrant application security testing. In the past, they split it in dynamic, in static, in integrated, in hybrid, whatsoever. This time, HP is the leader in application security testing. Last but not least, I would like to give you a quick glimpse on how this looks like in practice. Because I know if you're not coming from a development department, it might be quite abstract. Because code is a different thing. If you never typed a line of Java code, .NET, C++ code, it seems to be maybe quite, hypothetical, but it's not really. It's a proven approach, and it works. And this is the most important thing. So I will start with static code analysis. You remember the architecture? In the first step, the code is translated, or the application is translated into the Fortify intermediate model. Then the Fortify global analysis runs. That means we understand the whole logic, the control flow, the data flow of the application, and then map it against the vulnerability database. This is a three-step closed process. This is what you see, nothing. You just see a progress bar. You need to finish until the FPR report, the Fortify project repository, is completed, and then the project security lead is the first one to look at this. So what he sees is an overall representation of the findings. In the center, organized by colors, he sees critical, high priority, medium, and low priority findings. In the top, he gets all the details, when the scan was performed, what the build ID is, so he can do also trending and versioning. He sees how many lines of code have been scanned, how many vulnerabilities has been found, and then he gets on the left-hand side a detailed representation what categories have been found. For example, in critical, and this is a critical field shown, and he sees SQL injections, cross-site scripting that have been identified. He can create own rules for his own organization to add security functionality or also QA-related, best practice-related rules that he wants to avoid. He gets all the results and all the support from the Fortify global analyzers. In this little flowchart, he sees exactly what Fortify has analyzed, what the application does, where information is coming in, where information is going through. And in the lower left-hand side is what we call a trace analysis, so he can easily follow and see highlighted. He sees in the center upper box, he sees really the source code, highlighted where the vulnerability is found, and then he can make a decision and follow and say, yes, this is an issue, and then he can file a bug, or he can decide, no, for this and this reason, or in the context how we intend to operate the application, this will not be a vulnerability, and mark it as not an issue, and then it's documented and not shown again. But the ones that are filed as a bug, of course, go back to the development team. They go on the bug tracking system, the development manager assigns them to the developers, and they open the ticket and have a link in there, and then see the same picture, just in the integrated development environment, the IDE plugin, and he sees exactly his source code, where it has been highlighted, there is a vulnerability with a detailed description of the issue, how it can be exploited, because we want to make sure that the developer understands why it's a vulnerability and why he's supposed to fix it. And last but not least, okay, he gets a detailed recommendation on how to fix this in his respective programming language. In this example, it's a Java code, so the recommendation highlighted in blue is also in Java code. If he does ABAP, the recommendation will be in ABAP or C++, whatever he's using. And then he fixes the issue, checks the code back in, and hopefully, if he did it right, next day it's gone. And keep in mind, if a developer does this 2-3 times in a row, he will not produce an SQL injection the 4th time. So eventually, an organization will, over time, train their developers to produce secure code right in the first place. Last but not least, a penetration test might follow. This is very straightforward. Proven technology, you start a scan, it crawls through a web application, tries to explore with more than 3,000 attack patterns, each and every explorable link in an application, and you see online when something has been found, it is raised. And from there you can drill it down and go back to the developers and try to identify the real root cause in the source code as well. Last but not least, we have the opportunity, if you're interested in trying to get a glimpse on how static code analysis works, there's a free trial. We offer static and dynamic assessments as also as Fortify on demand, so as security assessments out of the cloud, which some organizations like Nestle, Kraft Foods, Royal Bank of Scotland really use quite heavily. And here you can get a trial, upload some Java code, and see if you have vulnerabilities in your code. Thank you very much. Any questions? Otherwise, I will be around all day at the Hewlett-Packard booth in front of the plenum. So if you have any question or want to have a live look at the solution, just contact us. We'll be glad to answer all your questions. Thank you very much.